in joules done on the surroundings when 1.19 liter of an ideal gas, initially at a pressure of 5.87 atmospheres, is allowed to expand at constant temperature to 11.19 liters by reducing the external pressure to 0.62 atmospheres. So from the lecture outlines, our process is something like this. So we have a piston, and underneath that piston is 1.19 liters of gas, and the pressure is 5.87 atmospheres. That's our starting point. And our ending point is 11.19 liters. So almost, well, my picture is not going to be perfect, but let's draw it way up here. 11.19 liters at 0.62 atmospheres. Yep. And does that even, yeah. Okay. And so now we have 11.19 liters. And what we're going to do is the equation for work. So first off, let's talk about why this is work. So this piston has been moved back. So what is the work? Piston has been moved back. And so the gas has expanded and it has done work. This will move back as gas expands. And that motion, if for a car piston, would then drive the car wheels. So again, we're connecting this to work, work that we can actually use to do something. So gases also expand and turn turbines that generate electricity. So it's a pretty general phenomenon, actually. But the equation is very simple. It says work is equal to minus pressure times delta V, where minus pressure is always the final pressure, and delta V is the volume final minus the volume initial. So our final pressure is 0.62 atmospheres. Our volume final is 11.19 liters. And our volume initial is 1.19 liters. And if I multiply this out, it will not give us units of joules. We're going to have to take care of our units. Let's see. We'll take care of the math first. 11.19 minus 1.19 gives me exactly 10 times the 0.62, 6.2. My units now are liters times atmospheres. And we go to our conversion and equation sheet. Somewhere. Oh, a lot of homework. Conversion and equation sheet. I buried it again somewhere. Oh, there it is. On your conversion and equation sheet, right here, it says 1 liter dot atmosphere equals 101.325 joules. So now we will convert liter atmospheres into joules. So 1 liter atmosphere is 101.325 joules. And so 6.2. And mine's positive, but it's negative here for my answer. There we go. Times 101.325. I get minus 628 joules. So it's not doing a lot of work, but it's doing some work. And isn't that amazing? Okay, let's see. Did I cover everything? Yes. Oh, the minus sign. So the minus sign means that the system, which is the gas under the piston, the system, which is the gas, is doing work. And another way of saying it that we'll talk about in another minute is that the system, so work is leaving the system. And when a reaction when a reaction is the system, and when the reaction is doing, or energy is leaving the reaction, it will also be negative as well. And the system versus surroundings is something that we don't directly ask questions about, but we will talk about it a little bit here. Any questions about this problem?